e to the xy times y times another y. Took the derivative of e to the w times w prime. That's the w prime, another y. Plus, we're taking the derivative of x stuff times a constant. 3 will come down, multiplied by the 4. We'll have 12x to the 2, y to the 4. And then the derivative of 10x is just 10, multiplied by the constant that's there, y to the 3. So that's the derivative of that one. And then for the x derivative, or that's the double x, done. Now for the y derivative, we'll start over here. This is e to like 3y. Taking the derivative of e to the 3y, we're going to get e to the 3y times 3. So e to the xy times x. Now we do a similar thing we did to the previous side. We have constant times y to the 4. When we take the derivative of that, we're going to get a constant multiplied by 4y to the 3. And then for the next one, we're doing the same thing. We're taking constant times y to the 3. We take the derivative of that. We'll get the 3 will come down, multiply by the 5. So 15x squared y squared. Now we take the derivative of that again with respect to y. We have constant times e to the w. We'll get constant times e to the w times w prime. So e to the xy times x times another x. Plus, we take the derivative of constant times 4y to the 3. 3 will come down, we'll get a 12. Let's still put that 12 in front. X to the 4, y to the 3. I could have done that. Could have put this 4 in front here, but just for the sake of being fast, I didn't. Last one, we're taking the derivative of constant times y to the 2. The 2 will come down, we'll get 30 x squared y. And that would be the double y derivative. Last question. We're asked in the last question to find the second partials, using the second partials test, find and classify all the critical points of the function. Okay, so second partials test requires us to first get the critical points. To get the critical points, we have to take the f sub x and f sub y, and then set both of them to 0. So f sub x first. Derivative of x cubed is 3x squared. Derivative of y to the 3 is 0, because we're taking an x derivative. Derivative of negative 3xy is negative 3y, and the derivative of 27 is 0. We set that to 0, we get 3x squared minus 3y. Okay, so far so good. Now we do the y derivative. F sub y equals, we're taking the derivative of x to the 3 with respect to y, we get 0. Then the derivative of y to the 3, we get plus 3y squared. Derivative of negative 3xy, take that derivative, we get negative 3x, and the derivative of 27 is 0. Set f sub y to 0 and clean it up. So 3y squared minus 3x. Got some choices here. I can either isolate for x in the second equation and substitute it into the first, or I can isolate for y in the first equation and substitute it in the second. I'm going to substitute for y in the first because I feel like it. Add 3y to both sides. 3y is equal to 3x squared. Divide both sides by 3, so we get y equals x squared. And sub it into the second one for y. So 0 equals 3 times that y thing squared is now x squared minus 3x. So 0 equals 3x to the power 4 minus 3x. I'm going to common factor out 3x from both pieces. We'll have x to the 3 minus 1 left over. And we can solve that. The first one, 3 times x being 0 requires x to be 0. And x cubed minus 1 being 0 requires x to be 1. So we get 2 x values. For each of these x values, we'll get the associated y values. If x is equal to 0, y equals x squared, so y is equal to 0 squared.